Does this look familiar? Urban highway congestion is a familiar sight in almost every metropolitan area. Traffic slowed down, backed up, stalled. What can be done to help relieve this congestion? How can we effectively increase the highway's person-moving capacity and provide more efficient transportation in congested urban areas? The Shirley Highway, Interstate 95 in Northern Virginia, approaching Washington, D.C., was originally constructed in the 1940s as a 4-lane limited-access freeway. Reconstruction under the interstate program has recently turned the facility into an 8-lane freeway, 3 lanes in each direction with 2 reversible lanes in the median. A 5-mile completed section of 2 reversible lanes was opened to buses only in September 1969 as the result of a feasibility study funded by the Federal Highway Administration. As early as 1964, bus-only ramps funded under the interstate program were designed for 3 interchanges to allow exclusive bus access to the reversible lane. During the reconstruction of the Shirley Highway, a temporary busway was constructed for 4 miles, connecting the completed roadway to a new bridge leading to the District of Columbia. Funding for the $2.8 million temporary roadway was also under the interstate program. A total of over 16,000 person trips are made on the exclusive bus lane during each peak period. Morning ridership since 1969 has increased from 2,000 to 10,000 commuters at a survey point midway along the exclusive lane, an increase of over 400%. At the height of the reconstruction on the Shirley Highway, buses using the temporary bus lane were receiving a 30-minute time savings over automobiles. Upon completion of the reconstruction in 1975, the 2 permanent reversible lanes will also be used by carpools with 4 or more occupants. Although the 2 lanes could not be justified for bus-only use, the addition of carpools will enable the continuation of preferential treatment to high-occupancy vehicles. In California, another busway was opened in January 1973 in the Los Angeles metropolitan area. The 6-mile first stage of the San Bernardino Freeway busway is located along the median of the highway. The bus lanes, 1 in each direction, are separated from the regular freeway lanes by a shoulder. The second stage of the project will complete the 11-mile busway. This second stage will not be located in the median, but will be adjacent to the freeway. The busway and 3 stations will cost $53 million. Roadway construction of $40 million is being financed under the Interstate Highway Program. 100 new buses are being purchased with assistance from the Urban Mass Transportation Administration. The best approach to a highway public transportation project is to combine the programs of both the Federal Highway Administration and the Urban Mass Transportation Administration. Bus patronage has doubled in the early stages of operation, with estimated volumes of 17,000 two-way passengers expected upon completion of the busway. As part of the project, the busway operation will be evaluated with data collection continuing through 1976. In April 1970, an exclusive bus lane was inaugurated in the 17-lane toll plaza area of the San Francisco-Oakland Bay Bridge. The morning peak period lane was 1/2 mile in length. 500 buses were able to bypass heavy congestion and save 5 minutes in travel time. Bus tolls were also reduced. In December 1971, the bus lane was expanded to include carpools with 3 or more occupants. The length of the reserved lanes was also expanded. This allowed all high occupancy vehicles to benefit. an exclusive lane was not placed on the bridge itself, since the bottleneck causing the heavy congestion was in the toll plaza area. The toll booth area now has 3 lanes reserved for high-occupancy vehicles, 2 lanes for carpools, and 1 lane for buses. Tolls were reduced to a minimal charge of $1 per month per carpool with a permit system. Carpools with permits thus do not even stop at the toll booths. Carpools without permits are allowed to use the lane, but must stop and pay the toll. Vans containing up to 12 passengers take advantage of the carpool lanes. These vehicles can provide service to those areas where densities are not high enough to support the use of 50 passenger buses. The introduction of carpools and van pools into the bus priority treatment did not cause a reduction in bus patronage. Another reserved bus lane is in operation on the New Jersey I-495 approach to the Lincoln Tunnel. This exclusive bus lane uses an underutilized lane in the light traffic direction. The lane is closed by a series of signs and traffic barriers during the peak period to provide an extra lane for buses in the direction of predominant traffic flow. About 50 traffic signs are used, most of which are changeable, to display different messages depending on whether the lane is operating or not. A locked gate prevents access when not in use. The gate is manually opened before the morning peak period. The average flow in the peak period is 40,000 passengers on 950 buses. In the peak hour, 21,000 passengers are carried on 485 buses. The lane width is only 11 feet with no shoulders, but no problems have developed. The project was funded through a $500,000 federal grant under the Urban Corridor Demonstration Program. In addition, the New Jersey Turnpike Authority provided needed bus access ramps at a cost of $134,000. 350 cylindrical plastic traffic posts separate opposing lanes of traffic. These posts fit into drilled holes in the pavement. Problems with traffic cone knockdowns caused by backdrafts from the buses were avoided by the use of these posts. Lane directional signals were installed on overpasses and sign bridges. Placed over the center of each lane, these signals show either a green arrow or a red X. A tow truck is maintained near the lane for emergency use. Because the lane has no shoulders, a disabled vehicle must be towed away immediately. Since its inception in December 1970, the bus lane safety record has been excellent. The highest flows on the bus lane approaching the Lincoln Tunnel were experienced during transportation emergencies created by commuter railroad strikes. During the peak period, nearly 50,000 passengers were carried in this one lane. The bus lane performed perfectly, with no stoppages and no delays. A contraflow exclusive bus lane located in New York City was started in October 1971 for Manhattan-bound buses in the morning rush hours. The project is located on the 2 miles of the Long Island Expressway from the Brooklyn-Queens Expressway to the Queens Midtown Tunnel. Over 200 buses carrying 10,000 people are being directed through a cut in the median barrier onto the special lane. The lane is similar in setup to the New Jersey exclusive bus lane, using posts and cones to separate buses from other traffic. The buses are averaging 3.5 minutes on the 2 miles to the tunnel. Traffic traveling the same distance in 3 regular westbound lanes is averaging 18 minutes. Total startup costs for the exclusive lane were less than $50,000. Daily operating costs are about $500. The lane allows buses to bypass congestion in the Queens Midtown Tunnel Toll Plaza area. Buses proceed through the tunnel and into the Manhattan Business District. Public response has been favorable. and demand for express bus service into Manhattan continues to grow despite premium fares compared to local buses and subways. The express buses provide a no-transfer ride direct from residential areas to the central business district. Another contraflow lane is in use north of the Golden Gate Bridge. Here again, the bus lane is in use on the roadway near the bridge, but is not in use on the bridge itself. Buses cross over onto the opposite side of the median barrier after crossing the bridge. An 80-20 directional split of traffic permits the closing of 2 of the 4 lanes in the non-peak traffic direction without existing traffic being delayed. One of the closed lanes acts as a buffer between opposing directions of travel. Thus, a 12-foot shoulder is provided. As in New Jersey and New York, cylindrical plastic traffic posts are used. These posts are manually placed before the lane is activated for buses and removed at the conclusion of the operation. The Golden Gate Bridge, Highway, and Transportation District has been providing expanded bus service in this corridor since January 1972. New buses are in use with financing from the Urban Mass Transportation Administration. Since this new service has been provided, bus patronage has doubled. In all these highway public transportation projects, it is important not just to provide a bus lane, but to provide frequent bus service to utilize the lane. In other areas of the country with less congestion, the provision of a special bus lane on a freeway may not be necessary. Buses may utilize the regular freeway lane, but preferential treatment may be necessary at entrance and exit ramps. In Seattle, Blue Streak Project buses utilize exclusive bus ramps but travel on a freeway in mixed traffic. In Washington, D.C., preferential bus access to the freeway is also provided during the morning peak period. Since congestion and delays are common on downtown city streets, it is important to provide some preferential treatment for buses on these streets as well as on freeways. In certain cases, bus-only streets are a good method to speed the flow of buses and the handling of buses, as in terminal areas or transfer points. Use is limited, however, to streets where access to local businesses by other traffic is not required. A more common method is to provide a curb lane for buses and right turns. However, a large number of right turns may present a problem, and from a law enforcement standpoint, it is sometimes hard to distinguish turning traffic from actual violators of the bus lane restriction. However, a strict enforcement program can overcome these problems. If right turns do clog the bus lane, restricting the curb lane to buses only may be justified. An analysis must be made of disruptions to traffic flow in any of these proposals, since the prime objective of any system is to maximize the flow of people. Contraflow bus lanes, such as this one in San Juan, Puerto Rico, provide bus-only curb lanes, which are virtually self-enforcing. Since bus lane operation is in a direction opposite that of other traffic, violators are very noticeable, and this high degree of visibility provides the deterrent necessary to enforce the bus-only restriction. These full-time contraflow bus lanes were implemented at low cost along 2 6-mile lengths of existing one-way streets. A double line painted on the pavement separates these lanes from other traffic. The operation was a success from its start in May 1971, with increased patronage, increased revenues, and time savings of about 33%, or 20 minutes over the old bus route. In addition to technical assistance, the Federal Highway Administration participated in the paving of these bus lanes as they passed through an interchange of the Manos-Rivera Expressway. Contraflow bus lanes are also in use in Seattle, San Antonio, Honolulu, and here in Harrisburg, contraflow